Hello. I thought I should start recording some videos and tutorials and discussions about Unity 3D development because I've been doing this a long time and have a lot of experience and have been on lots of different Unity projects and it's been pulled into lots of different Unity projects to diagnose them and offer advice on their design and architecture and um, I've come to realize that lots and lots of people out there are all now new and getting into Unity, and this is a great time where I can pass on some of the uh, pay it forward, so to say, so that the new people coming in can learn. And I noticed that there's a number of topics that I see new people are getting into and struggling with and wondering about that I sorted out like 10 years ago for myself. And so to get into this, what this video is going to be about is it's going to be about MVC in Unity. This is a subject that often comes up with newer people in Unity for a number of reasons. They're looking for a way to do proper architecture in Unity or make their Unity project more manageable, and they hear about MVC and they see some things about MVC, and then they start wondering, how do you do MVC in Unity? Should MVC done in Unity? And the simple answer of it, I would say, is absolutely do not do MVC in Unity. It is a complete it's a completely confused notion to say let's do MVC in Unity, and I will explain why. I made some blog posts. Well, first, if you want to know who I am, here is my GitHub page, rygo6. I have a link to my LinkedIn right here. You can go look over my resume and stuff I've worked on in the past, and decide for yourself if you want to trust someone with my background in having knowledge on this worth listening to. But yeah, my GitHub here, LinkedIn to LinkedIn, and then on my blog, I had done some posts on this years ago. Starting with forget about MVC and Unity, ECS not MVC, and then most recently controller is probably a bad name, and I would still think these are pretty good articles to read through, and I linked to the other ones also in this article, ECS not forget about MVC and Unity, and this explains some of the reasonings of why I say you should not do MVC and Unity, and I have it spread over 3 blog posts, but really, I could even do even more blog posts concerning this, but it's kind of exhausting, and I actually felt like this was a pretty done discussion like 5 years ago when I made this initial blog post, because I had wandered my way, I guess, into the section of the country and Unity developers that had not been conceiving of anything in MVC land. I think it's because I started working with more people who had background in actual like game engine development rather than web and mobile developers. People who come from a mobile app background or a web development background tend to want to do MVC and Unity because like Android and iOS are still MV architectures, and some web app frameworks are also still like MV or MVC architectures. And so people who come from webs and 2D UI, they come to Unity as their first 3D engine, and they want to carry that perspective on, whereas people who come more from other game development backgrounds and 3D game development backgrounds and 3D game engines, I think tend to not do that because it's 3D game engines actually run on a different kind of fundamental architecture, and I'll get into the explanation of why this is. And the other thing uh, about this that I notice now is I decided to type MVC and Unity in Google again, and lo and behold, there is a lot of new content of people talking about doing MVC and Unity. And like the first result is this Top Towel article saying Unity with MVC, how to level up your game development. And this article to me is just uh, I don't want to criticize it too much because like I can obviously tell the author is a very smart person, but I feel like he's doing the thing that so many people have done when they come from mobile app background and they're starting to move into 3D game engine. Like I've seen it in so many projects and so many that they come into 3D land and they're like, well, MVC worked in all my 2D iOS applications. Let's just now figure out how to stick MVC on Unity. And it's a logical extrapolation, but there's a really fundamental error in it. And the error in it is that it's very different problem domains. And to get into, so model view controller, if you're watching this, hopefully you know like model view and controller, MVC, and the model is the object which interfaces with a database or some kind of backend API doing CRUD operations and performing other business logic on that data. And then a view represents an actual like 2D view in your 2D user interface, like a button or a panel or something. It describes only the visual representation of it. And then the controller binds the model to the view so that the controller figures out what to forward to the view and what to operate on the view and all that. And it's largely done for decoupling and a separation of concerns. And I want to first highlight that I don't think MVC itself is bad. MVC is actually a pretty decent conception of architecture, evidenced by the fact it's lived on for like, started in 79, the 70, yeah, it's like it's over 30 years, or no, 40 years, I'm getting a lot older these days, but yeah, it's lived on for a long time, and like Apple and Android are still have derivatives of MVC, so it's a very good architectural design. It is very good. The thing about it, though, is that this was conceived of for the architecture of 2D graphical user interfaces. It actually spawned out of Xerox Park in the early days and like their early GUI stuff. And it's first implemented on Smalltalk 79. That's interesting. But yeah, commonly used for developing user interfaces. And this is really where it came from, is that it was an architectural pattern for 2D user interfaces. That's literally what it was conceived of for. I found this nice layout of some iOS panels, and when they came up with MVC, what they were doing was they were looking at this. Well, not literally this, because of course they didn't have Android back then. They were looking at some really old, very crude UI on like the first Xerox computers, but they were looking at, UI panels, and they were saying like, what are the fundamental behaviors present in this? And they identified, well, we have a view, which is a window, or not a window. A view is a panel, some sort of collection of 2D interface elements and only their presentation. And so they labeled the visual representation of a UI, they labeled that a view. And then they were like, well, we need to operate on a database. What is, and we need to do logic. So what are we going to have? We're going to have a model. And there is literally another object that served this literal purpose in the concept of 2D user interface. And then they're like, well, we need something to drive the interfaces, so, talk to the models and drive the interfaces. Well, what do we call it? Well, we call it a controller. And this is the thing to understand about MVC, is that these concepts of model, view, and controller were conceived of by decomposing the behavior of 2D user interfaces. They were derived from the things that needed to literally exist in the context of a 2D user interface, that there was actually a literal view. And it was literally a panel that just described the view of the panel, and that actually existed in the context of objects. It was a required behavior in that environment, and so that's where view came from. And then they needed the behavior of interfacing with a backend and doing logic on the data returned, and so that's where the concept of the model came from. And then something to read and control it to, and that's where they needed the behavior of the controller. You know, we have three categories of behavior here, which are very well tuned to this specific use case of 2D user interfaces. But now let's go over to a different problem domain. Here we are in Unity. The first thing I'd hope you notice is that this is not, well, the Unity editor is a 2D user interface, but your game world is not a 2D user interface. Your game world is something very different than a 2D user interface. In here you have cameras to move around, you have shapes, you have lights. It is much more complex than a 2D user interface. Not this at the moment, but you know, if you made a whole full game with players running around and things that could explode and items to pick up and a whole game, it's like there's much more here than just elements of a 2D user interface. And this is where the abstractions in here come from, where here you have a light, and so you literally have the concept, the abstraction of a light. Here you have a camera, so you literally have the concept, the abstraction of a camera. Here you have meshes, which this is actually, these are decomposed into a few different behaviors for differing reasons, but you have a mesh filter and a mesh render and a capsule collider, and you have a collider concept because you literally have a collider. You have a mesh renderer because you literally have something rendering a mesh. And this is the thing to understand, is these abstractions in the problem domain of a particular system. The abstractions come from describing the literal decomposed elements of necessary fundamental behaviors. And this is what MVC is, but for the context of 2D user interfaces. It's the literal behaviors necessary to construct 2D user interface. MVC are not universal abstractions. They're abstractions describing behavior of a very particular use case. And so this is the weird thing about people now saying, let's do MVC in Unity, is that they're taking a much simpler problem domain, a much simpler environment of behaviors, which with just a few simple, like three very simple abstractions of types of behavior. And then they're coming to a much more complex problem domain, which is fundamentally different than a 2D user interface. And they're saying, let's take all these more complex abstractions describing the literal fundamental behaviors of a 3D interactive environment. Let's take all those more complex abstractions and try to fit them into the abstractions conceived of from a completely unrelated problem domain that is far, far simpler. And it literally just makes no sense. And I think the only reason people are doing this is because they just don't know this is what you're supposed to do as a system architect, and they don't know this is what MVC came from, that they're spent probably most of their time in a mobile app background or a web app background using all MVC, and everything was MVC, and so then they leave that and they're like, MVC is this great architectural pattern. Let's do everything in MVC, and they don't, uh, maybe they knew, maybe they forgot, maybe they never knew, but MVC wasn't a universal set of abstractions for every problem in existence. They were abstractions which literally described the actual existing behaviors which underlay specifically 2D user interface. And so they continue on and try to contort the thing, and it's a really bad idea. And I this article is really, it's a well-written article, but it's just not a good article. And the author does note that Unity is an entity component pattern. This is the fundamental architecture that Unity runs on, and a lot of game engines run on, is an entity component architecture. Unreal runs on it. Half-Life engine ran on it. Did it start at Quake? I don't remember where exactly it started, but this is one of the very predominant patterns in 3D game development. A Godot also runs on this type of pattern. And it should be noted that the entity component pattern is different than the entity component system in Unity, related in some conception, but these are kind of different things. And he goes on to say where entity component falls short, and that he says in large objects we are still too free, and we can find ourselves in a feature ocean, having a hard time finding the right entities and components or figuring out how they should interact. There are an infinite ways to assemble entities and components for a given task. This is actually the whole point of an entity component architecture. But to continue on, he then says, I see that there's 3 categories, and these map to MVC. Some handle the raw data, allowing it to be created, read, updated, deleted, or searched. Others implement the interface for other elements to interact with, detecting events related to their scope and triggering. Finally, some elements are responsible for receiving these, making business logic decisions, deciding how the data should be manipulated. Are those really the 3 categories of behavior in a game engine? Sorry, I wasn't showing the page. This is the page. Yes. Are these really the 3 categories of behavior? And he says that these come to distill down to model, view, and controller. Let's go back over to any. Really, there's 3 categories here. Actually, let's go look at the Unity documentation. Let's look at this. Let's look at all these 2 free components describing way too many concepts. Android input. Wait, can't scroll to current version. Classes. Yeah, so let's go audio clip, audio configuration, audio distortion filter, audio source, avatar, avatar builder, behavior, bit stream, box collider, cache, canvas, canvas group, collider, contact point, debug, frame. Like, yeah, this is I guess you could say how did he describe it? Um, a feature ocean. It's too free. Look at all these different behaviors that have been identified for the problem domain of 3D interactive environments. This is a lot of complexity. How do we manage this complexity? Well, we fit it all into three concepts. Three concepts derived from 2D user interfaces. Uh, no. It just makes no sense. It makes no sense whatsoever. If you go through here and you started to rename all these things to collider controller, uh, collision, model, color model, component controller, contact point model, crash, if you started to go through and categorize these things into these three categories, this isn't going to make it more manageable. It's not. It's going to make it worse because, for one, there's way more categories of fundamental behavior to derive from in a 3D interactive environment. And then, two, the categories of behavior that you're now trying to fit into a new set of abstractions to make it more manageable are a set of abstractions that were conceived of as literal descriptions of a completely different problem domain. So this is why I say no. Let's not do MVC in Unity. Let's not take the abstractions from a completely different problem domain and then try to fit a completely different problem domain that is innately more complex, innately requires more categories of behavior, and fit them into this other simpler set of abstractions from a completely unrelated problem domain. It kind of just blows my mind that like this type of article makes it to the top of Google. And there's so much written about this. And I really can only think of it because there's just so many new people coming in from mobile app and web backgrounds that don't know the things I just explained, don't know where MVC came from, don't know why it was conceived of as a good architecture in its problem domain, and don't know why, and don't really understand what entity component architecture is. I think it's primarily just because the people are so familiar and so spent so much time with MVC and spent so little time with entity component architectures. And it's funny to me that if you type MVC and Unreal Engine, the first result that comes up is a Reddit thread asking about model view separation and Unreal Engine, and the first response with the most upvotes is, I've never seen anyone use MVC or MVVM or anything like that in a game. If I'm to be honest with you, even if the separation of graphics and logic is possible, I really don't think it's worth the hassle to work against the grain of the engine. Exactly. It's funny to me. MVC and Unity returns this like article from a very somewhat known website that's just like whoa. And then the first result in Unreal Engine returns just simply no. What the hell are you thinking? And I think that probably has a lot to do with the people coming from mobile and web background. They aren't initially going to Unreal, they're initially going to Unity, and so the higher concentration of people that come from game engine development and game engine architecture backgrounds have taught these things a little better as the users trickled into the Unreal community, but Unity just got over flooded with people who had really no idea about this stuff. And so with all that said, though, I would like to... How long is this video? I don't have a timer. Let's just go as fast as possible. I would like to, though, highlight how you approach entity component architecture, because I think this is what people struggle with getting, is they don't get the entity component architecture and how you can design systems in it that are manageable. And they haven't seen enough of it, so they don't really realize what it looks like when you're doing it appropriately. But we come back to just the basic principle of object-oriented design, in that what you do, in the same way this was done with MVC and 2D user interface, is you put your problem domain in front of you, whatever the visual problem domain is. And this is one nuance of this, is object orientation I don't think is itself universally applicable. And if you start to get into problem domains which don't have like literal representations of objects, that's when starting to approach things more in a functional programming style makes sense. But if you're in a problem domain where there are literally objects in an environment, that's when object orientation makes a lot of sense, and that's where you start from this approach of object-oriented design. And it starts with looking at what are the literal objects actually existing in your environment. And for a user interface, it was a 2D view. And in here, iOS also has the abstraction of a window, because there's a window, obviously, and I think Android also had that abstraction. But they look at what are these actual things, and they derive backwards from there. So we have a view, we have a window, and then we needed something for database, something to Gloom controller, and that's where the taxonomy and the abstractions come from, starting with what is literally there as the objects. And so we then go to Unity, and this is the same thing being done here. You start with what is literally there, and you name it literally that. And then you work backwards from there. And if you need some stuff that's a little more, sometimes you do end up with objects that don't have literal counterpart or like literal representations in the environment that you can see, and you do end up with these objects that run on more abstract concepts. So one of the examples of this is the canvas system in Unity, which is, the canvas system is a 2D user interface, but it's a 2D user interface implemented through entity component architecture. So it's actually different, even though it is still a 2D user interface. Interestingly, I'd like to highlight this, that Unity does have a new user interface library in development, and it is actually been released for production for use in the editor. And that new 2D user interface called UI Elements does in it have actual views. It has literal views in the same meaning as MVC. And so you actually could be doing MVC in Unity with this new UI system, but it would be a 2D UI in your 3D environment, and the conception and abstractions of MVC would be constrained to that 2D UI. But back to this canvas system, which is Canvas is 2D UI done in entity component pattern. So one thing about this is, this is decomposed into by behaviors. And this is one of the nuances about this to understand, is some people, I think, tend to believe that MVC might see what I'm saying as kind of a semantics argument of like, oh yeah, but you still have controllers and views, you're just naming them differently. And this actually is not true. This isn't true. There is it informs a different kind of architecture when you start approaching things as entities and components that MVC does not inherently inform. And what I mean by this is, if we go to Android and their user interface, Here's the Android documentation where they have views, and views kind of go in a hierarchy of, like, you have a button view on a panel view on another view, and this is actually gets laid out in an XML format now that you lay out in the editor. Views also can traditionally be just a class that describes placement and coordinates of the layout of elements, but more and more you have these editors that lay them out in XML. But when we come into Unity, what in here is most literally a view? Over here in Android land, it's the hierarchy of views, UI elements stacked on each other, related to each other, and stored over in an XML. And if we come back to Unity, what is that over here? The literal closest thing. It's your scene and your scene graph. And then the arranging of the components on them, which describe the description of it. And this is one of the weird things if you're trying to do the MVC in Unity, and why it's not really just a semantics argument, is that, for one, there literally is no equivalent of a view in the context of a 3D interactive environment that needs to be created as a component. Like, you're trying to turn a component into a view, but what the view literally is closest to being is your scene and your scene graph. And you don't need to rename that to something else. You can just call it scene, or call it your scene graph. And this is what I mean by, these are not universal concepts. You shouldn't be taking the abstractions from this problem domain and sticking them to other problem domains. You should learn your specific problem domain and derive your abstractions from that specific problem domain. So the view, or the scene graph, in your scene is what describes the arrangement, placement, and description of all of your visual things you can actually see. And then we come over here to the components, and this is where how Unity implements the entity component pattern is you have game objects, which are your entities, and then you stack components on them. And the way components are supposed to work is they're supposed to describe composable behavior. That's the purpose of them, describing composable behavior. And this is where it gets kind of weird when you come into the concept of controllers and views in relation to this, because you could say that this is a view, but it's also implementing logic, because this has a number of operations in it that just describe its behavior, how navigation gets to it, how these things fade and display, and it inherently doesn't have a split of or separation of concerns, separating what can be neatly conceived of as a view and a controller. If you were to do that in here, what the view would be is the view would be the serialized data of the button component, and the logic, or the controller, would be the C# code of the component. But you see, you're taking something just a completely tangential perspective and trying to contort it to fit here. The way you're supposed to view this is, here's your entity, and here are your components, which compose to describe its behavior. And so what you first do is you look out into the scene and you say, what is actually existing here? Well, we have a button. We have a literal button. So what are we going to do? We're going to make an abstraction called button. In the same way that when they were looking at 2D user interfaces and they're like, what do we literally have here? A view? We're going to make the abstraction of view. Here you have the literal abstraction of button. And so you end up with a component of button. Here you have a literal image. And so you end up with the abstraction of image. Here you have literally an object with text. So you end up with the abstraction of text. And you start from there. You start with what your literal objects are and go backwards. And you do get to points where not all of your objects will have literal representations in the world, and this is when you start need to come up with more abstract concepts to relate them. One of these more abstract concepts is the canvas renderer, or a renderer. Obviously this doesn't have a literal existence in the world, but it's still serving a behavior in the ecosystem of all of your other objects and components. And then canvas, canvas scalar, canvas group. And this is one of the nuanced thing about it, is if you kind of really go through and think of what each of these things are doing, some of these could be said to be more like controller concepts, or they could be more like view concepts, or some deal more with presentation, some deal more with logic. And because like canvas scalar is really just dealing with the scaling of canvases, so maybe that's a presentation component. The buttons dealing with just like the logic of a button, so maybe that's a controller. And you know, you can go through and kind of do this, but really all these components are a mix of both. They're all a mix of both because it's not trying to because it's starting with what I just described. It's starting with looking at what's literally there and working backwards from what's literally there to describe the abstractions. And people come in here, and I've heard so many people say, like, we need to separate the logic from the presentation. Do we? In some contexts, I would agree with this, but you know, follow me through here on as I explain this. Is that really what you're looking for in a more fundamental sense is the separation of behaviors. If you have a behavior that needs to deal with presentation, you end up with that as a separate concept. If you have a behavior which deals with some kind of logic not explicitly bound to that presentation, you end up with that as a separate object. But you don't separate concerns based on abstract concepts like presentation and logic. You separate your concerns based on the elements of behavior that literally exist in your environment. And so here is how, you know, I think the Canvas system is actually a pretty good example of how you do an entity component design. It's interesting also to see it because it's a 2D UI framework, so you can relate it to how architecture ends up in MVC versus this. But the way you end up with these things separated here is not with presentation components and logic components, but with components which represent what actually exists. And through that is where you can start to, uh, from that is where you can start to split things off into different categories of behavior as you need them, as you only as you really need them. Because this is another thing about entity component architecture and MVC, and kind of a difference from MVC is you don't you have to actually kind of work through the problem domain and the architecture of it to really get a sense of what the different behaviors are that you need. Sometimes you can sit there beforehand and just say, like, these are all the different behaviors I need, and you can come up with them right off the get-go. Sometimes you need to, though, implement something, the behavior of something, and you realize that actually this component can be decomposed into multiple behaviors. And you decompose it in different ways as are necessary for what you're specifically working on. And so in this context, you have a button and you have these uh, colors, normal color, highlighted color, which describes how these get affected. And one thing that I wish actually the Canvas system did is that this functionality of color was further decomposed into another behavior. And you could just call this like a color color schema or color palette is what I've called it in the past, as a palette. And you just store, you'd have one object which is a scriptable object which stores nothing but a color palette, and then you would be able to load this into here. And then you could have multiple buttons sharing the same color palette. Unity already has this kind of implemented with presets, where you can save a preset, but it's kind of a little bit of a different system, I think, because the presets don't automatically update all the things they're connected to. But that's one fundamentally different take on how you approach this. Is you don't just make one blanket statement on what your separation of concerns would be for literally everything. Like, again, just cruise down like the Unity documentation and imagine all these things having corresponding controllers and corresponding views. It literally would make no sense to do this, because a blanket statement of what your separation of concern should be doesn't make sense. You have to figure that out as you go and as you need to separate things out into different composable behaviors. Like audio, for example, they have audio clip playable, audio mixer group, audio mixer playable, audio mixer snapshot, audio playable binding, audio playable output. That's, yeah, can you think of how to fit those abstractions into the concepts of controller and view? Well, no, it would make no sense, because these are abstractions derived from an audio clip playing in a 3D environment alongside other audio clips, and controller and view are abstractions derived from a 2D user interface. Doesn't make any sense. And so this is how I generally approach doing these things. Is you start with what literally exists in your environment, and then you break it out into components as is necessary to further decompose the behavior to enable the behavior to become composable on other objects. And you don't actually want to decompose it into multiple components unless that actually introduces new behavior that can be composed in different ways. One way to think about this is that your game object here and then your components on it, you can almost think of it as like a visual scripting system. But instead of chaining together nodes, you're dropping logic blocks in a stack to describe the behavior. And if in a visual scripting system you had two visual nodes, and those two nodes could only connect to each other, and those two nodes always had to be connected to each other, and there's no other configuration by which those two nodes could disconnect and configure to other things. Like if you had two nodes and they explicitly could only be connected to each other and had to be connected to each other, those are not two separate behaviors from the perspective of a visual scripting system. Those are one behavior, and they should be one node, because it would just be pretty silly to have two nodes that you always had to drag both of them out and connect them every time you wanted to use them, and they would never be used in any other way but that. And that's kind of the same mentality that I think you should take when designing components, where if you have a component, it's actually okay to do it as one mono behavior that encapsulates a whole bunch of things, but you only keep it as that until you start to discover the behavior that should actually be broken out so that it can be composable to produce different kinds of behavior. And one example of how I did this is I have these item objects in my game, which items are things you can drag out in the world and place around. And I started this first with just an item script or an item component, and this described all the data of the item and how you could drag the item around and what you could place the item on and what you could do with the item. And I was going along with just item for a while until I realized that, okay, the dragging behavior of the item doesn't always need to be there. Sometimes I want it to not drag. And then you can also drop the item on other things. So I have an item drop component. And then also at times you needed a gizmo, and so I have a item gizmo component. And as I went on, I discovered these new categories of behavior. And because there are new categories of behavior that didn't necessarily need to always be included in the behavior of the first component I was working on, I broke them out into new components. And so now you can compose the behavior of an item by composing different components. And this is the point of doing it in this manner, is so that you end up with many different composable components. And to the point of this original article that says it's I don't know where that article that you turn into a feature ocean and it gets hard to manage. This is an appropriate statement. It does, and this is what the whole point though of like good architecture is that you need to take a lot of care to describe your abstractions and identify the categories of behavior and name those categories of behavior appropriately and keep the naming consistent, the categories of behavior that components perform consistent. And this is already done in Unity to some degree. There, you have the abstraction of a renderer, and they reuse this multiple places and you can reasonably assume that wherever there's a renderer, it's rendering something in some manner. And the same thing with the abstraction of a collider. They have box collider, cylinder collider, all these different colliders, and you can be reasonably assured that if something is named collider, it plays the behavior of colliding with something. And so that's you do end up having to deal with a more complex set of abstractions and something more difficult, but that's because it literally is more complex and it literally does need more abstractions than what were needed for 2D user interfaces. And one point I'd like to note is that when you go along and do this, you do this item component or item entity I did manage to turn into some generic composable behaviors. And that's good for this. But there are times when you end up not actually decomposing the behaviors into different components that much. And one of the places that this tends to not occur in practice for me is with the component that I put at the root of a menu. And this component is actually pretty similar in its behavior to a literal MVC controller, because this holds a bunch of references to a whole bunch of things that are presentation oriented, and then it implements logic, and it does and it receives and interops with databases. And so this is probably like the most controllery type thing that exists in my games, is the UI component that I'd put at the root of a UI next to a canvas. And this is though what I mean of, it's like I'm not explicitly saying MVC is bad. I'm saying that its abstractions are the product of decomposing a specific problem domain. And if in your new problem domain, going through the same process of how you decompose objects into, decent object-oriented design, if you end up with a similar concept, then that's great. In this case, I did. This is kind of like a controller. But an interesting thing to highlight here too is, in this, back on the item, is this is composed of multiple components to construct its compound behavior. And in a way, all these components combined are like the controller. And if I was following more strict MVC here, I imagine I would probably end up with an item controller, which had all these different components put into it. And that is where thinking in an MVC context can actually be very counterintuitive to the entity component architecture, because it's better to have decomposed components to recompose into new kinds of behavior, so that you end up with a library of components that you can combine in every which way to make new behaviors without having to code new things. Like this is better, and you actually don't want to do this unless you truly don't need to decompose it further. You don't want one component which has a bunch of references and does a bunch of logic. If at some point I discover that actually there is a certain behavior in this component that other UI needs to share, I will pull it out of this component, turn it into a new component, and then multiple UI will start to share that component. But that is what you always want to aim for: decomposed components that can be recomposed in new ways. And you do end up with a lot of components, but that's where becoming an architect and managing this stuff comes into play. And I have a blog post here that if you want to get some idea of this, it's called "Controller is Probably a Bad Name" on this blog here. But I brainstormed and wrote up just some types of behavior that I end up using in projects: sequence, catalog, factory, root, container, render, API, UI, menu, database, datum, item, piece, part, pool, group, wrapper. Like these are all fairly decent abstractions of behavior that you end up with if you derive it off of your actual 3D environment. And this is by no means like an authoritative list. There's even more that you could come up with, but just to start to get an idea of the types of things that you can further decompose into, you can read through this list. And I usually recommend that as teams develop code bases and libraries, they keep a rolling log like this internally, where someone will propose a category of behavior and they'll name it, and then they'll describe what that behavior is, so that anyone making a new component that has a similar behavior can name it the same thing. And this is how I think you end up with a good architecture in an entity component engine that is based on that architecture, is just putting a good amount of thought and good description into what your categories of behavior are. Another thing I'd like to note is that in the context of Unity and game engines, one of the concepts of MVC that does transfer over pretty decently is the model, because you do end up with uh, objects in Unity that just do CRUD operations to a database or do just implement logic in some way. And the thing about this, though, is I usually prefer not to call these things model, because in the taxonomy of a 3D game engine, the abstraction of model is already taken by 3D model. And the name model wasn't even, I think, the best of names either. You know, it comes from decades ago. And what I find is that when I start to create a model object in Unity, what it is doing is it is implementing an API, or it's interacting with a database, or it's being a kind of service object, or it's just holding data to pass around. And what I prefer to do is literally name it what it specifically is. So if it's an API that's just doing CRUD operations, name it an API. If it's interacting with a database, name it database. My game database, my game API. If it's providing some kind of service, um, that's a little more of a generic name, but what did I write in this? Any component which is to be universally accessed either in a scene that never unloads or has been marked do not destroy. Database, API, and wrapper could all be better names if they better describe your component, but sometimes you may end up with service components. Yeah, so in a way, service is kind of like a more generic descriptor of something that could be a model. Same thing with manager, same thing with system. Uh, these could all be kind of interchangeable things because they're a little more abstract. So if you use these terms, you'd probably want to put some more specific description to them, or go off my specific descriptions. I describe these as a system is the entry point into a more complex system, um, and a manager needs to hold many references to other things. These are my concepts, though, that I'm inventing, and each code base will probably end up with a little bit different conceptions of these behaviors. But as long as the behavior is, decently consistent across the components which use those namings, and you're not going completely counter to the types of abstractions that are already in the Unity API, then I find code bases that go in that route are do end up well. They end up good and relatively easy to manage, and they scale well. And new people are easy to onboard into it because if everything's named well and the categories of behavior are described well, then it becomes decently self-documenting. And so that's the way I think you should really approach architecture in Unity, is work backwards from what's literally there in your environment and come up with abstractions of behavior that are as literally descriptive as possible, and don't necessarily decompose things into different components of behavior unless you really need to. I would add one note, though, that even if you do have one component, even if you do have one component that has a lot of logic and code in it, and it doesn't make sense yet, or maybe ever, to decompose this component into multiple components, you shouldn't necessarily just write a massive component with thousands and thousands of lines of code. Instead, what you should do is internally decompose some of that logic into just plain C# objects, not Unity components, but just C# objects, which can be created, instantiated inside of the class itself and held as private references inside the class. So some of that logic can get pulled out of the main class and put into subclasses to help make the main class smaller and categorize parts of it internally better. And that's also something to consider as well for sharing behavior or logic between components, is that it may be possible that shared logic doesn't always need to be an additional component. That shared logic could just be a C# object that multiple components internally instantiate and keep a private hidden reference to. There's times when you do that because the real reason for making a new component is exposing something to be controllable in the inspector. That if your new component introduces behavior that has fields on it that need to be set, or references that need to be set up, or something like that, that's usually when you want to make a new component and actually do that. Otherwise, you probably don't want to like pollute your component library with concepts and abstractions that aren't really necessary to be understood. Again, thinking of components as kind of like a visual scripting stack is relevant. You wouldn't want to put in a method or operation into a language which your user will never need to use or offers no real additional functionality or configurability on top of what it would just do by default. So some things to think about, and hopefully this can help people in understanding how to better approach entity component architectures and why MVC is a bad concept in the context of 3D interactive games, or specifically Unity.